Hi, I'm Aishwarya. Over the past 8 years, I've spent most of my career building and operating cloud platforms. One thing I gradually realized is that platform teams aren't actually limited by visibility. They are limited by the time it takes to turn visibility into a decision. Cloud Trail, Guard Duty, IAM reports, Cost Explorer exists, and we have a bunch of observability tools, Grafana dashboards, Datadog, etc. The difficult part is bringing those signals together into something an engineer can trust and act on. That's the core idea behind this project. If you have worked in cloud operations, this scenario is probably very familiar to you. On a very typical Tuesday, finance team notices cloud spend is increasing and security is investigating domain credentials. On the other hand, operations has another guard duty finding waiting to be reviewed. So here, nobody is missing information. The investigation starts because every service tells one part of the story. Someone still has to go back, connect the pieces before a decision can be made. And I wanted to see whether that investigation could begin with a question instead of another dashboard. AWS already provides an excellent operating tool. The interesting challenge wasn't visualizing findings, it was correlating them. Data transfer. And CloudTrail event might explain an unusual API activity. And a public S3 bucket becomes much more important when another finding changes the context around it. And that's what I wanted to improve. So that thinking shaped the architecture, which we are viewing right now. Collectors continuously gather operational findings from multiple AWS services, and those findings are normalized, embedded, and indexed inside Postgres using pgvector. So, one design decision was particularly important to me here. I deliberately separated retrieval from generation because when a question arrives, the application retrieves the relevant operational evidence first. Only then, Claude running on Bedrock reasons over that context. Because I don't want a language model answering from general knowledge. I wanted it to reason over the evidence collected from this environment. Operational trust doesn't come from confident answers, right? It comes from traceable answers. Every response can be followed back to the findings that produced it. Rather than walking through features, I'll ask a few operational questions to the interface I've developed. So these kind of questions platform teams deal with every day. There are questions around privileged access, unexpected cloud spend, where we have cost anomalies, and understanding operational risk. The interesting part isn't whether the model can answer, it is whether the answer gives an engineer enough context to decide what happens next. Let us start with the basic question of which IAM users haven't logged in for 90 days and still have access keys. Alright, here we have a detailed answer. Let's start with the categories we have. We have the users, IAM users, and how many days they have not been logged in for. And we have one more user called dev contractor and who is not logged in for 134 days. Alongside these findings, we also have some more uh, answers here. So we have a relative priority here. We also have the security concerns combined as an output here, what it means in business translation, what are the operational consequences. And alongside, this is the best part I liked about the model, where it gives a remediation sequence. So since it's an IAM user, I get the commands on revoking it and then creating access keys. This model does not change anything in the underlying AWS infrastructure, rather gives a finding along with reasonable answers for any engineers to view it. Let's ask one more question from a cost perspective. All right, now the question is around the cost anomaly I've noticed in my account. Here, I get a comprehensive response around first AWS data transfer, the cost on it, and the date where the data transfer was very high. And it also captures other services. We have S3 and EC2, because of which costing got increased. And alongside this, we also have what it means in business translation how much the billing attributes can impact, and we have some recommendations here. So the recommendations are basically how could we handle our instances, optimizing the suggestions. They are also given here. Let's go to our one last question around blast radius. All right, here we have it. Here we have the findings around the blast radius. So basically, it starts with the S3's encryption issue and versioning issue, and the CloudTrail findings around the API calls. And we have CloudTrail findings along the API calls. So these are relatively very useful information when we are trying to identify and secure our AWS account. And it really gives the potential affecting areas where platform teams can look into and start working on the improvement. We also have a remediation sequence here. A comprehensive output like this for every queries we are trying to process around the accounts, and it is all evidence backed from real time services that are running in the accounts. These help us to visualize and prioritize where we can spend our energy and what we can work on improving, because currently most time is spent around multiple tools and finding the areas that we are lacking right now. Rather, this tool helps us to spend more time around what we can enhance and improve or identify the gaps we have, rather than spending energy on the discovery process. Building cloud platforms all these years helped me understand finding problems is rarely a difficult part. Rather, helping people understand which problem matters is usually a challenge. So, this project was my attempt to bring infrastructure knowledge, operational context, and AI together in a way that supports the decision making process. Not by replacing engineers' judgment, but by helping engineers get to it faster. Thank you for watching. See you in the next demo. Bye. Telemetry exists. Cloud trial